All right, so just like when we were solving equations, we are going to have a few special cases when we're solving systems of equations. So this is page 15 of your purple packet, and we're going to cover two special types of linear systems. So remember, in order to solve a system of equations, both equations need to be in slope-intercept form. So for this first example, which you need to write down, y equals 2x minus 3 and y equals 2x plus 4, we already have both equations in slope-intercept form. So this top equation, I'm going to graph in red, has a y-intercept of -3. So I'm going to put a point on the y-axis at -3. And my slope is really 2 over 1. So I'm going to go up 2 and over 1, up 2 over 1, and I'm going to continue on that pattern, plotting as many points as I can. And I'm also going to work backwards, down 2, back 1, down 2, back 1. So this is the graph of my first equation. My second equation is y equals 2x plus 4. So that has a y-intercept of 4. And its slope is also 2 over 1. So up 2 over 1, up 2 over 1. And I can work backwards, going down 2, back 1, down 2, back 1, until I fill up my entire graph. And so solutions happen when two lines cross. So if you notice, these two lines are never going to cross because these two lines are parallel. So parallel lines never cross. So this, we would say, has no solutions. Circle with the line through it. Remember, that means no solutions. So that's the solution, that there is none, to the first equation. So let's do this as our second system. Y equals -3x plus 6 and 9x plus 3y equals 18. So the first equation is good to graph. It's in slope-intercept form, so we're good to start. So my y-intercept is 6, and my slope is -3 over 1. So that means instead of going up 3 and over 1, since it's negative, I'm going to go down 3 to the right 1. Down 3 over 1, down 3 over 1, down 3 over 1. And so I can't work backwards at all, it won't fit. So that's my line. The second equation, though, is not in slope-intercept form. So remember what we have to do with equations that are not in slope-intercept form. When it's written in standard form, we need to rewrite it in slope-intercept form. So to do that, I first get rid of the x by subtracting 9x from both sides. And so I'm going to get 3y equals -9x plus 18. And I'm going to divide the entire equation by 3 to get y by itself. And -9 divided by 3 is -3x. 18 divided by 3 is 6. So if you notice, it's actually the same exact line as the other one. So if I graph this line in blue, it's going to have the same y-intercept, and I'm going down 3 over 1, down 3 over 1, down 3 over 1. It's the same exact line. So if you want to know where do these lines cross, well, they cross everywhere because they're the same line. So my solution here is infinite solutions. Remember, we do the two lines and the R to show infinite solutions because that symbol really stands for all real numbers. So if a system of linear equations has one solution, the graph will cross at one point. If a system of linear equations has no solutions, the graph will never cross. Oops, never cross. They will be parallel. And then if it has infinite solutions, the graph will always cross or be the same line. So if you graph it and it's the same exact line, that's all real numbers or infinite solutions. So those are three special cases.